the definition of fluid pressures. So you know that the pressure is nothing but force per unit area. So it is the force exerted per unit area. So force is measured in newtons, whereas area is measured in meter square. So therefore the unit of fluid pressure is Newton per meter square. You also know that 1 Newton per meter square is known as Pascal. Um, you know that the fluid is capable of flowing, but when you store water, that is when you store water, that is in the water tank or maybe in the reservoir, where the water will be at rest. Since the water is at rest and is not capable of sustaining shear stresses, so we don't have any component which is tangential. Okay, so tangential to the boundary. So when the liquid is confined within the boundary surfaces, then the pressure is exerted by the fluid at rest on the boundary surfaces, and this pressure exerted or this pressure force exerted will be always normal to the surface or normal to the boundary surfaces. So it is normal to the boundary surface because when the fluid is at rest, so then the fluid cannot sustain shear stresses, so therefore there cannot be any tangential component parallel to the boundary. So therefore the only force will be the normal force, and this normal force um, uh, exerted on the surface is known as fluid pressure. So the fluid pressure is nothing but the normal force exerted per unit area. So it is required to find out the variations of pressure in a fluid at rest. That is, we are going to derive the fundamental equation of fluid statics. For this, we have to consider a fluid element of length delta x, delta y, and delta z in x, y, and z directions. The vertical direction taken as z, so this is the x direction, this is the y direction. So similarly here delta x is in the x direction, then delta y is in the y direction, and similarly in the vertical direction taken as delta z. Now let the pressure be P at the midpoint. Okay, so if the pressure is P at the midpoint, we are required to we allow the pressure to vary. So right at the beginning of this derivation, we don't know how the pressure varies. So therefore here, if the pressure is P at the midpoint, that the CG of the fluid element, so the on the right plane, that is BHGC, the pressure increases, and so on the left plane like AEFD, the pressure decreases because it is on the negative side. So therefore if P is the pressure here at the midpoint, so here the pressure will be P plus the some increment. So how to find the increment? So increment is got by knowing the rate at which the pressure is changing. In what direction? In x direction. So that means it is rate is dou P by dou x. What is the distance? The distance from the midpoint to the plane will be delta x by 2. So if you multiply the rate with delta x by 2, you will get the increment of the pressure. So therefore it has to be P plus dou P by dou x into delta x by 2. If you multiply, this is the pressure intensity acting on this, okay, on the plane BHGC. If you multiply by delta y and delta z, you will get the area, so that gets converted to pressure force. So this is how it is written. And similarly on the negative plane like AEFD, the pressure has to decrease, so so therefore the pressure force has to be P minus dou P by dou x into delta x by 2 into delta y into delta z. Like this, we are required to find the pressure variations along the y directions. So here this is positive, so this is a front plane, like A, B, C, D is the positive plane, whereas E, F, G, H is the negative plane. So therefore the pressure intensity increases on the plane A, B, C, D, whereas the pressure intensity decreases on the plane E, F, G, H. So therefore the variation is along the y direction. So if the pressure is P here, so the distance from the midpoint to the plane, that is A, B, C, D, is delta y by 2, because the distance between the front plane and the back plane is delta y. So half the distance you have to take. So therefore it will be, so like P plus the rate of change is dou P by dou Y into delta Y by 2. Area is delta X into delta Z. So similarly on the negative plane it will be P minus dou P by dou Y delta Y by 2 delta X delta Z. Now coming in the Z directions. So now you know that this is plus direction. So therefore the plane AEHB is the positive plane where the pressure increases, whereas the plane DFGC is the negative plane where the pressure decreases. So therefore we have the pressure here, the variation is along the Z direction. So it is P plus dou P by dou Z delta Z by 2, because the distance between the top plane and the bottom plane is delta Z, so half the distance is taken. So area is delta X and delta Y, so therefore that gives the pressure force. Similarly the negative here on the negative plane the pressure is P minus dou P by dou Z delta Z by 2 into the area is delta X and delta Y. So now we have marked all the pressure forces acting on the each of the faces. So apart from this we also have what is known as the weight of the element. So here let omega be the specific weight of the fluid element. So specific weight is weight by volume, so therefore weight is specific weight into volume. So what is the volume of the fluid element? So it is delta X, delta Y, delta Z. So therefore here it will be specific weight to delta X, delta Y, delta Z. Now the next step is to write the equations of equilibrium. So since the fluid element is in equilibrium, then you can apply the condition sigma fx is equal to 0, sigma fy is equal to 0, and sigma fz is equal to 0. So that you will get the fundamental equations of fluid statics. So the same figure is once again written so that it will be easy for you to write sigma fx is equal to 0. Similarly, sigma phi is equal to 0 and sigma fz is equal to 0. So I have explained here that you have to consider a fluid element of size delta x, delta y, delta z, and so the forces acting are the pressure forces which are acting on each of the face, and also the sulfate of the fluid element is shown in the figure. So now how to write the pressure is also said. So the pressure intensity at the midpoint is P. So then the pressure intensity on the left side will be reduced, which will be P minus dou P by dou X delta X by 2, and the pressure intensity on the right side will increase, so P plus dou P by dou X delta X by 2. So the pressure forces are always compressive, so therefore it is towards the face. So in each of the cases, so if you want to convert pressure intensity to the to force, so you have to multiply by the area. So pressure intensity is multiplied by the area delta Y delta Z, so as the pressure forces are shown in the X direction. Similarly you can show in the Y direction as well as in the Z directions. And also the sulfate is marked which is acting at the midpoint of the element, where the weight of the fluid element is omega, that is specific weight, into delta X, delta Y, delta Z. Delta X, delta Y, delta Z is the volume of the element, so volume into specific weight will give the. Now again, since the fluid element is in equilibrium, we have to apply sigma fx is equal to 0. So here so anything in this direction, X direction, is positive, so this will be positive and this will be negative. So therefore it will be P minus dou P by dou X delta X by 2 delta Y delta Z minus P plus dou P by dou X delta X by 2 delta Y delta Z. So this is what you will get. So if you multiply P into delta Y delta Z, so you will get So P delta y delta z minus dou p by dou x dou, dou p by dou x. So you will get delta x, delta y and delta z by 2 by 2. Then this is minus, so this is minus p delta y delta z. So this will be minus into plus is minus. So dou p by dou x. So again you will get delta x, delta y and delta z divided by 2 should be equal to 0. So this gets cancelled out. So you're left with minus and minus. So dou p by dou x is common. So delta x, delta y, delta z by 2. Delta x, delta y, delta will be delta x, delta y and delta z. So therefore it will be dou p by dou x. So delta x, delta y and delta z should be equal to 0. Okay, with the minus sign. So therefore dividing by delta x delta y minus delta x delta y delta z, so we will find that dou p by dou x will be, so dou p by dou x is equal to 0. So what does this mean? That if you take integration of this with respect to x, then p will be a constant. So that means the pressure will remain constant along the x direction. Along this, so there will be no variations of the pressure along the x direction. If the pressure is p, it will be same throughout along that particular horizontal plane. Similarly, we can write sigma fi is equal to 0. So I have taken this as positive this side. So therefore this will be positive. So p minus dou p by dou y delta y by 2 delta x delta z. So and this will be negative. So there are no other forces in this direction, only two forces. So therefore it will be p minus dou p by dou y. So now again here p delta x delta z minus p delta x delta z will cancel out. So you're left with dou p by dou y delta x delta y delta z by 2, and here again delta x. So again as we have written here also it will become, so this will get cancelled out with this. So therefore what is remaining here? So it is delta x delta y delta z by 2, delta x delta y delta z by 2. So it will become dou p by dou y into delta x delta y delta z should be equal to 0, dividing by delta x delta y delta z. So therefore dou p by dou y should be equal to 0. So if you integrate this, the pressure is again constant in the y directions. So now you can see that the pressure, there is no pressure variations along x direction as well as in the y directions. So now what about in the z directions? So when we write the expressions here, so this force, that is p minus dou p by dou z delta z by 2 delta x delta y is upward. So we have taken according to this sign, which is positive. So this will be negative and this will be again negative, which is acting downwards. So therefore when we write sigma f z is equal to 0, it is like this. So p minus, so dou p by dou z delta z by 2 delta x delta y. So now here you can find that this, so this will get cancelled out with this because p plus and this is minus. So now we have again same thing as previous case. So minus and this minus, so dou p by dou is delta x delta y delta half and half will be 1. So if we cancel throughout delta x delta y delta z, so then you will get, okay, so dou p by dou z is equal to minus w. Okay, is equal to minus w. So it is not 0 here, it will be minus w. So how to write this? So it will be minus, so minus dou p by dou z, dou p by dou z. So here it will be half and half will be delta x delta y and delta z. So this half and this half will be delta x delta y delta z, and this will be minus w delta x delta y and delta z should be equal to 0. So dividing by delta x delta y delta z, so it gets cancelled out. So we can write that dou p by dou z is equal to minus W. That okay, so now you can say that there is a pressure variations along the z direction. So that means by z direction is nothing but the vertical directions, so that it is a function of z. So minus sign indicates that as we that is upward is the positive directions. As we move upwards, pressure goes on decreasing. As we move downwards, the pressure goes on increasing. So that's the variations of the pressure. So therefore, now continuing further with the okay, so that gives dou p by dou z. So for example, so this is not dou p but dou y. So dou p by dou z is minus w. Okay, so what does it indicate? So equation 1, 2, 3 indicates that the pressure intensity at any point in a static mass of fluid do not vary in x and y direction, but varies only in the z directions. That means a minus sign indicates that as z increases, that is z increases in the upward direction, as z increases, the pressure intensity decreases, that is in the upward direction. So as we move upwards, so pressure decreases. As we move downwards, the pressure increases. Okay, so this is what you should understand. So now if you integrate this, so we will get, if integration omega is a constant, so it will be integration of 1. So integration of 1 is z, because you're integrating with respect to z, so it will be p equals minus omega into z plus some constant of integrations. So what is this p? Is is the pressure at any point or at any elevation z in a static mass of fluid, and c will be the constant of integrations. Now it is required to find the value of c by boundary conditions. So this is the expressions that you need. So p equals minus w into z, because integration of 1 is z, plus some constant of integration. So that is what I've shown here. So now this is if you consider a fluid which is at rest. Okay, here, so let the point be here. So therefore, if you consider any point, say here, so it is you say, suppose this is the datum, some reference point, so from there the value is z. So therefore p is omega into z plus some constant of integrations. So now you consider any liquid of height h, capital H. So let this height be, say, something like z0. So now you know that if you take any point here, the elevation has to be z. So okay, elevation has to be z. So suppose this point is at a depth small h. Okay, then z will be equal to h plus z0 minus this, minus h. So is this. Okay, so now you know that this is a free surface. On the free surface, atmospheric pressure is acting. So now if z is any variable quantity, so z is measured from here. Suppose you come over here, z will be equal to z0. If you come to this point, then z will be equal to h plus z0 minus h. If you come here, so z will be z0 plus capital H. So this is this is a variable quantity. At any point, it is the point is referred with respect to the datum. So that is nothing but the z. So now we have what is known as p equals omega z plus c. So you have to find the constant of integration, for which we should know the boundary conditions. The boundary condition is that at z equals z0 plus h, here the pressure is known. The pressure is atmospheric pressure. Okay, so which is PA. So for example, the pressure is here is PA. So which is atmospheric pressure. So now if P becomes PA, this is a constant. What becomes z? Z is nothing but z0 plus h, because we have reached this point from the datum. So now you can find out the value of c. So now substitute. So at z equals h plus z0, so pressure will be equal to atmospheric pressure. If you substitute in equation 4, so pressure becomes PA minus omega, z becomes h plus z0. So what is c now? C will be PA plus, okay, omega into h plus z0. So now take this value of c from equation 5 and substitute in equation 4. So now if you substitute, so here minus here, okay, so minus omega into z. What is C? C is PA plus omega to h plus z naught. So simplifying this term, so now write this PA here, so omega, so h plus z naught minus z. Okay, so what is h plus z naught minus okay, h plus z naught minus this h will give you z, will give you h, for example, minus z. Okay, so h plus z naught, so total height minus this z will give you this h. So therefore the equation becomes PA plus omega into h. So now this is the expression. So that means if you want to find out the pressure, if you want to find out the pressure at any point, you should know the height of that point from the free surface, or the vertical height of the point from the free surface. So because this is a constant quantity, so here the pressure is PA. So as you move downwards, the pressure goes on increasing, so therefore this is the plus sign. So as we move downwards, pressure increases, so it will be PA plus omega into h. So if you know the distance, so what is the pressure here? So pressure is PA plus omega into, what is the distance till here? It is capital H. So the pressure will be PA plus omega into capital H. Like this, if I want the pressure here, it will be PA here, and as pressure increases, it is plus omega into whatever the distance. For example, the distance is say 1 meter. Okay, so now you take PA is the atmospheric pressure plus specific weight of water is 9.81. So 9.81 into 1 will be so much kilonewton per meter square. Now all pressure measuring instruments, when they are exposed to atmosphere, it will read 0. So therefore PA will be read 0. Okay, or it will read the pressure in excess of the atmospheric pressure. So therefore all measuring measure instruments when exposed to atmosphere will read 0. So therefore it will read only omega into h. Okay, that PA will be taken equal to 0. So such type of pressures are known as the gauge pressure, which I will come later on to that particular topic. So therefore here taking PA as, because it will read 0. So now what will be the pressure that it reads here? It will read like specific weight of water is 9.81, because if it is water 1 meter you have come down, so 9.81 into 1 is 9.81 kilonewton per meter square will be the pressure read. So now the equation will be as simple as like P equals omega into H. So therefore I have written that. So it here it is here because P is equal to omega into H, since specific weight of water is a constant, it depends upon only on the vertical depth of the point below the free surface and the specific weight of the liquid, and it in nowhere the shape or a size of the container is important for us. So only with the vertical depth of the point below the free surface is required to find out the pressure. So therefore the pressure depends only on the vertical depth of the point below the free surface and specific weight of that particular liquid, but not on the shape or the size of the container. So now since the atmospheric pressure is a constant, I told you earlier that PA will be taken equal to 0. So or often in excess of the atmospheric pressure is always measured. So equation can be written as P is equal to omega into H. So this is the fundamental equation of fluid statics, which will be often used in almost all the problems that I will be discussed later on. So coming to the pressure head. So as I told you that P is equal to omega into H. So H can be written as P by omega. So this is P is always kilonewton per meter square. This will be in kilonewton per meter cube. So kilonewton per meter square divided by kilonewton per meter cube will give in meters. So therefore this is always measured as in meters of that particular liquid. So whichever liquid you are using, so for in that in that terms it will be expressed. Like if suppose we have something like 100 kilonewton 100 kilonewton per meter square uh, as the pressure. So specific weight of water is 9.81. So approximately, so 9.10, 100 divided by 10 is 10 meters. So therefore the height of the water that it stands for this particular pressure is 10 meters. So that means if the pressure somewhere here, so somewhere here is 100 kilonewton. If you fit a, so something like a manometer or a piezometer, right? So depending upon the pressure, the water will rise to this level. Okay, so this height will be 10 meters, approximately 10 meters, because I have taken 9.81 as 10. So 100 divided by 10, so is 10 meters. So now the pressure here will be 100 kilonewtons per meter square. So what did I tell for the pressure head? It is nothing but, suppose the free surface is here. Free surface is always exposed to the atmosphere. It is the height of this free surface above the point where you measure the pressure. So from the point, if you go up to the free surface, that will become H. So this is H. So therefore you should understand that H is equal to P by omega. So it is nothing but the vertical height of the free surface above any point where above any point in a liquid which is at rest is known as a pressure. To same thing, you can always, so it depends upon, say suppose you are taking specific weight of oil. So therefore this H will be nothing be expressed as meters of oil. Suppose you take mercury. So you take 100 kilonewton and divide by specific weight of mercury, then it will become meters of mercury. Similarly, if you take petrol, so if specific weight of petrol, specific gravity is 0.87, so here this will become 0.87 into 9.81. So then H will be expressed in terms of petrol. So that means whichever liquid that you are using, depending upon the pressure, whatever height that it gains that is the vertical height of the free surface above which the pressure is measured in a liquid at rest, is known as pressure head. So you have to understand this very clearly so that it will be useful in the problems. So there is one more important law which is known as the Pascal's law. So Pascal's law states that the pressure at any point in a fluid at rest has same magnitude in all the directions. So here when you take a fluid at rest, so suppose the pressure is say P1, so in all the direction it will be P1, so like this. So P1, so like this. So that is what I'm going to prove there. So it will be P1 like this in all the direction. So suppose the same here along the same plane, okay, if I take, so since this is P1 in the horizontal direction, I told you P1, so here also it will be P1, because now everywhere it will be P1. Okay, so same pressure will get transferred along the horizontal plane. Okay, so this is what you should understand, because I told you that there is no change in the pressure along the horizontal plane. But at a point the pressure will be same throughout. So this is the same magnitude in all the directions. But when you move along a plane, if suppose this pressure is P1 here, uh, okay, so the pressure here also will be P1 only, if uh, along the horizontal plane. So if this is P1, I told you at a particular point, if P1 is acting in all the directions, P1 has to act at this particular point. So this, okay, how to prove this? So now you have to consider a wedge shaped element. So wedge shaped element is taken. So here z is the vertical direction, we have x, so the delta x is in the x direction, delta z is in the z direction, and similarly the this is delta y, which is in the y directions. Here this length you can take it as delta z, which is at an arbitrary angle alpha. Now if Px is the, so I want to prove that Px should be equal to Ps should be equal to Pz, then only this Pascal law gets proved. So therefore if the pressure intensity is Px, it is acting over an area delta y and delta z, so therefore we convert it into force, that is Px into delta y delta z. Similarly, if I want to consider in the z direction, so it's always compressive force, so let Pz be the intensity, so area is delta x and delta y. So like this. So this is the plane it is acting. So delta x into delta y. So similarly, if I consider on this face which is at an arbitrary angle alpha, so now here always force is normal to the face. Okay, if it is normal to the face, then PS will be the intensity, delta S into delta Y, okay, is the area. So therefore that is the force. But at what angle is it making with respect to vertical? So now this is perpendicular to this plane. Similarly, this is perpendicular to vertical is perpendicular to horizontal. If alpha is this angle, so this angle has to be alpha. So this you have to understand. To resolve it, we need. Okay, so now I have marked the forces which are in x direction, z direction, and any arbitrary angle alpha, which is PS. So that is what we have written. So again, coming to now resolving now since the fluid is at rest, we can resolve sigma fx is equal to 0. So when I take this, so px delta y delta z is, say, suppose taking this as positive, and now if you resolve ps, okay, in the horizontal direction, it will be sine alpha. So ps delta s delta y into sine alpha. So if I resolve this starting from tail and move towards the tip, so like this. So this is like this. Okay, so now I'm interested in this. So this will give me sine alpha. So therefore I have to write, so px delta y delta z minus ps delta s delta y into sine alpha. So what is sine alpha? Sine alpha is from the triangle which is delta z by delta s. So if I substitute here, okay, so delta z by delta s for sine alpha, so that this delta s and delta s cancels, dividing throughout by delta y delta z, I will get px should be equal to ps. Okay, so this is proved now. Now the pressure in the x direction is equal to the pressure in the s direction, that is ps. Now taking sigma fz is equal to 0. So now taking upward pz delta x delta y minus ps delta s delta y. So this will be cos alpha. So, and one more, we have the weight of the fluid element. So weight is nothing but specific weight into volume. So what is volume? Half delta x into delta z is the area into delta y will give the volume. So therefore area is half delta x into delta z, length is delta y, so I have multiplied by delta y. So that will give the volume multiplied by the specific weight. So that will be again acting downwards, so I have taken minus. So this is cos alpha here, which is taken as, so ps delta s delta y cos alpha. So now again, what is cos alpha? It is base by hypotenuse, so delta x by delta s. So now you substitute that here, okay. So therefore we have pz px delta y, so minus delta s delta y. Cos alpha is nothing but delta x by delta s, but since it is the product of three smaller terms, so the product will be still smaller, so it will be neglected. So neglecting this term, so now delta s and delta s cancels out, so dividing by delta x and delta y, so we have pz should be equal to ps. So now from equation 1 and 2 we can prove that px should be equal to pz is equal to ps. Since ps, this plane is taken at an arbitrary angle, it can go okay, it can be taken at it is any angle, so the plane goes on changing. So therefore now so that means, and the force ps is normal to the plane, so therefore it is proved that the pressure, if you take here, so therefore px should be equal to pz, that is x direction and z direction, and also in all other direction, which is ps. So therefore the pressure at any point in a fluid at a rest is same, same in magnitude in all the direction. So hence it is proved. So the next topic is the atmospheric pressure, gauge pressures, vacuum pressures, and the absolute pressures. So you know that the atmospheric air exerts pressure on all the surfaces with which it is in contact. The pressure exerted by the atmospheric air on the surfaces with which it is in contact is known as atmospheric pressure. So what is the value of atmospheric pressure? So if you consider 1 centimeter by 1 centimeter area, and then the height equal to height of the atmosphere, and the pressure exerted by the air column equal to height of the atmosphere, and acting on area of 1 centimeter by 1 centimeter is equivalent to 1.03 kg force per centimeter square. So that this is known as atmosphere, and this value is known as the atmospheric pressure. So atmospheric pressure is almost equal to 1.03 kg force per centimeter square, which is equivalent to the pressure exerted by the air column of 1 centimeter by 1 centimeter, and the height equal to the height of the atmosphere. Okay, so therefore here, since this atmospheric pressure is measured by barometer, is also known as barometric pressure. So here, what is the so atmospheric pressure is 1.03 kg force per centimeter square, is nothing but 9.81 newtons. Okay, and here the centimeter square is divided by 100 square, so therefore it gets multiplied here 100 square. So now the unit will become, so kg force is converted to newtons and centimeter square is converted to meter square, it will become newton per meter square. If you divide by 1000, you will get kilonewton. So therefore this answer is 101. So therefore 1.03 kg force per centimeter square is also equivalent to 101.3 kilonewton per meter square. Now you know that the pressure is, so you can convert into any like meters of water or maybe millimeters of mercury or meters of oil, anything. So standard practice is to measure in terms of water, like meters of water, and also in terms of meters of mercury or millimeters of mercury. So now how to convert this? So I'm interested to find the meters of water. So this 101, which is kilonewton per meter square, is divided by specific weight of water. If you divide by specific weight of water 9.81, then you will get meters of water. So atmospheric pressure is also measured in terms of meters of water, which comes to about 10.3 meters of water. So therefore, so you can also remember that H is 10.3 meters of water. Suppose I want to express in terms of millimeters of mercury, then H will be, so first take this pressure, is, you know that it is a standard value, which is 101.3, but since we are measuring in meters of mercury, so specific weight of mercury is 13.6 into 9.81, which is specific weight of mercury. So this gives 0.76 meters of mercury. So what is, so 0.76 or 760 millimeters of mercury. So therefore always we say that the barometric pressure is 760 millimeters of mercury. So if you want to express in any units you want or in any meters of liquid, so can always be take 101.3 kilonewton per meter square and divide by its specific weight, you will get that meters of liquid. Since we are divided by 9.81, which is specific weight of water, so therefore we are getting in meters of water, which is standard 10.3 meters of water. If you want to express in millimeters of mercury, you can always divide by specific weight of mercury, which is 13.6 into 9.81, so which gives 0.76 meters of mercury, that is equivalent to 760 millimeters of mercury. So next is the relationship between the absolute pressure uh, and the gauge pressure and the atmospheric pressure. Now this chart will help you to have the relationship between these pressures. Now it is seen that I had told earlier that all pressure measuring instruments, when they are exposed to atmosphere, will read the pressure as 0. So we call it as gauge 0. Or okay, so therefore here if you take this is atmospheric pressure. Okay, this is atmospheric pressure. If you start reading from here the pressures, so then if you take local atmospheric pressure as the datum, then it is known as gauge pressures. Okay, so so what is the pressure here? Since the atmospheric pressure is at 0, because this is atmospheric pressure, so therefore it is 0. Suppose here when you start measuring a pressure somewhere at this point, okay, so now since it starts reading 0, 0, 10, 20, 30, 40, something like that. Suppose here pressure is 70 kilonewton per meter square. Okay, so therefore it will read pressure here as 70 kilonewton per meter square. Okay, 70 kilonewton per meter square. Well, just one example, simply just okay, so here it will read 0. So from 0 it will start, and once it reaches this point, then it reads 70 kilonewton. So 70 kilonewton per meter, which is known as gauge pressure at A. So what is gauge pressure? So gauge pressure will read the pressure with local atmospheric pressure as the data. Now, so suppose I want to measure the pressure here. Okay, suppose this is something like 30. Now what it reads, it starts reading. So as we moved here, so because negative scale, this is positive scale and negative scale, so it will read 0, minus 10, minus 15, minus 20, 25, 30. So that means it will read minus 30 as the answer. So therefore this minus is known as vacuum pressure, or also known as a negative gauge pressure or section pressure. So with atmospheric pressure at the atom, if it starts reading negative values, then it is known as vacuum pressure or negative gauge pressure or section pressure. So this is about the positive gauge pressure and the negative gauge pressures. Okay, so in a complete vacuum, or if the pressure is absolute 0, and if the pressures are read with absolute 0 as the datum, okay, so it will take 0 as the datum, so then the pressure measured is known as absolute pressure. Okay, so now what will be the value of absolute pressure here now? So absolute pressure is, so when you start read from here, which is absolute 0 is that atom, so when you come it will go on reading like this, and when it comes over here, so what it should read, it should read atmosphere, because I said that this line is atmospheric pressure. So what is atmospheric pressure value? It is 101 point. It not because when the absolute 0 scale is there, it will not read atmospheric pressure as 0, so it will start reading 101.3. So 101.3, then it will go above because we have already said that it is 70. So 101 plus 70, it will read 171.3. So what is absolute pressure at A? It is atmospheric pressure plus gauge pressure, which is 100, say 101 plus 70, which is 171 kilonewton per meter square. Now, if you want to read the pressure here, what it will read? So it starts reading like when it reaches here, it is 100, 101.3 minus 30. So that means what is remaining here? So from here, if it starts reading, it will read 70. Like 101 is approximately 100. 100 minus 30, it will read 70. So what did you observe here? That is absolute pressure at B is nothing but atmospheric pressure minus gauge pressure. So again, in both the values, like absolute pressure at B as well as absolute pressure at A, are positive values. That was 171.3 kilonewton per meter square, and here it was, so I say 100 minus 30, so plus 70. So both, so absolute pressures is always a positive values, whereas gauge pressure will be positive if it is positive gauge pressure, it will be negative if it is vacuum pressure or negative gauge pressures. So now you understand that if atmospheric pressure is taken as the datum and read, then it is known as gauge pressures. If anything above 0, if it starts reading, then it is positive gauge pressure. Anything below 0, if it starts reading, then it is vacuum pressure or negative gauge pressure. But in absolute complete vacuum, there's absolute 0 pressure exists. So if you take absolute 0 as that atom and starts reading the pressures, then it is known as absolute pressure. So I told you that, so gauge pressure is positive if it is above atmospheric pressure and negative if it is below atmospheric pressure, but absolute pressure is always positive. So therefore, when you take pressure at A, absolute pressure at A will be atmospheric pressure plus gauge pressure. If you want to take absolute pressure at B, then it is atmospheric pressure minus the vacuum pressure. So therefore, one example which I gave is absolute pressure at A will be 100. Say for example, approximate to 101.3 means approximate to, easy to read, 100 plus 70, which is 170 kilonewton per meter square. Absolute pressure at B is 100 minus 30. So it will be 70 plus 70 kilonewton per meter square. But if you want to read as gauge pressures, so you start from 0, which is atmospheric pressure, it will read plus 70 at, so gauge pressure at A is plus 70, gauge pressure at B is minus 30, because atmospheric pressure is taken as 0. Okay, so this is what explain atmospheric pressure, gauge pressures, vacuum pressure, absolute pressure, and indicate its relative position by means of a chart. So then you have to represent like this, and then finally write the relationship, which is written like this. Okay, so this is about the theory that I was supposed to discuss, and with this theory you will be able to solve problems. There are because I told you that I always used to tell that the pressure is measured by means of some pressure measuring instruments. So that is, we have gauges which is fitted and we can measure the which is called the mechanical gauges. There are also what is known as the manometers, where and we can fit the manometers. It can be in terms of piezometers, it can be in terms of U-tubes. There can be a simple U-tube manometer, or it can be a differential. Simple U-tube manometers are used to measure the pressure at a particular point. If you want to find the difference of pressure between any 2 points, then you have to connect U-tube manometer to the 2 points. Like one limb is connected to one point, another limb is connected to the other point. So such type is known as a differential manometers. But simple U-tube manometers are that only one point is connected to the pressure point, and other point is exposed to the other limb is exposed to the atmosphere. So like this, when I don't want to go into the much detail and explain about all types of manometers, but when I take the problems, I will explain you how to connect the manometers to the gauge points, pressure points, and how to measure the pressures, and how to write a manometric equation. So based on that, you can solve the problems. So with that concepts, you can better understand manometers. So if at all, you can refer some textbooks for detailed study of manometers, which I will not be covering in this my lecture, because it is very easy. I will solve it. Those concepts I will explain once again in the problems. Thank you.